Great. Hey, like I said, we are so excited that you're here today. And you know what? These things take a lot of work to put on, and I just want to say thank you to a lot of people, really. First of all, a lot of teachers worked hard to get you here. So let's go ahead and give those teachers a round of applause. Okay. And we have some dignitaries that have just come in that are really making STEM a priority in our district. So I want to introduce Dr. Rob Paco is here with us today. Miss Juliana Stocking. And Trustee Cologne has joined us today. So let's give everybody a warm welcome. And of course, we have Mr. John Waggle, the principal of Tracy High, is here with us. All right. So we are going to get going now into our talk. But like I said, I just want to thank everyone for making this possible and being here today. Okay. All right. I got some questions for you before we get into our keynote. Our keynote speakers today. My first question for you is, how many people are on planet Earth? How many people are on planet Earth? I want you to think about that. Okay, anybody have a confident answer? Get those hands up. Who's got a good answer? You can take a guess. There we go. I see an answer. A hand up in the back. 7.2 billion. Maybe a little bit higher. Good guess. Anybody else? Yes. Yeah, we've just crossed that 8 billion mark. So there are 8 billion people on planet Earth now. Something I think we should all know and understand. That population's pretty considerable. Next question. How many cars are on planet Earth? How many cars are on planet Earth? Yep, I got a hand right here. 3 billion. 3 billion. Little high. What do you got? 1.4 billion. It's going to be different depending on the source, but it's a little over 1 billion cars now on the planet to move all those people around, right? We get in our cars, we travel, right? And we got to eat. We have to eat too. So, and a lot of us eat meat. Some of us are on plant-based diets. But a lot of humans on Earth do eat meat. How many cows do you think are on planet Earth? How many cows are on planet Earth? Any guesses out there? About 1 billion cows, okay? And last question, just to put the scale of what's going on into our minds. How many chickens are on Earth? How many chickens are on Earth? Okay. I'm just going to tell you what I found. Yeah, you got an answer? Go for it. 33 billion. That's what I'm kind of seeing, things like higher than 25 billion chickens. Okay? Because, hey, there's a lot of people, there's a lot of cars, there's a lot of food. That's a lot of energy that we use. And the reason why I bring it all up is because all of that human activity has impacts. And some of those impacts are on the environment. And that's really part of what this talk is about today. It's just something that I think we should think about, and we should think about sustainability. How do we live on a planet that has all these resources and all these people, and we want to do all these things, but we have to do it in a way that's sustainable? And someone that does a lot of thinking about that is here with us today, one of our community partners. So I want to invite Dottie Nygaard, president of the Tracy Earth Project. Let's welcome her to the stage.
Thank you, Dean. And yes, I want to extend a really warm thank you to Tracy Unified, Dr. Paco, and all of the teachers, the STEM teachers that helped coordinate to put this together. And especially Heirloom for coming today. So yeah, I was going to introduce us to you out here. So we have the Bulldogs, we've got the Jaguars, and we've got the Grizzlies, right? Okay, so I just wanted to make sure I did my homework right and that we have the right group in the room. So I wanted to just say that as the president of Tracy Earth Project, many of you may know us as the sponsor for the Tracy Bike Life Youth Program. So that program is to actually get more kids on bikes. It's a bike repair, earn a bike program. But you know, bike riding is definitely the cleanest mode of transportation. So we definitely have, you know, opportunities coming down the roads with more e-bikes and looking at how to, you know, get out of automobiles and less carbon-driven vehicles and be able to get around our town in a really clean mode. So besides, you know, our bike program, we also do tree planting. So twice a year we do 2 big tree planting campaigns to plant trees, because trees do remove a lot of carbon out of our atmosphere, but they also beautify our community, and they are also increase our canopy, our tree canopy, for that ever-needed shade in the summer when we reach those 110-degree weather heat days. So, you know, we have partnered last year with Tracy Unified and launched our very first Earth Day Challenge. We have the Stein winners here from last year. Great job that they did winning that trophy. And we hope that you can hold on to it this year, because that Earth Day Challenge is where we're taking all of you science-loving minds out there and challenging you to take a environmental problem, develop a project, and come up with a solution. And yes, you're awarded at our annual event and recognized with, you know, the trophy that goes back to your school, certificates and medals. But this year, we're very proud as an organization to say, we want to make sure you're valued more with your input on environmental impacts and how you are addressing our problems. We are going to award the top 3 winning classes an $1,000 award. So this is where we really want you to take this seriously. You can win $1,000 for your class on addressing a good environmental problem and coming up with a good solution. And there are so many out there, from very simple problems as far as just recycling on our own campuses. Do we have all the needed bins? Are we doing good food composting? To, you know, all sorts of complex problems like Heirloom that's tackling one of the biggest. And so I just want you guys to know that you all have a flyer that you received. We have information on the back of that flyer. We are looking for youth, because we want you to help us address these environmental problems here in Tracy. We want you guys to join our youth council and help use us as a platform and be able to really make an impact in our community to be more environmentally sustainable. And so with that, I hope I can get a few responses today. We look forward to having you join us. But without any further ado, I want to share with you Heirloom. Heirloom is a company that does direct air carbon capture. The very first facility in all of the United States is here in Tracy, in our backyard, where they use all sorts of different sciences. They have chemistry, physics, all sorts of innovative technology, robotics, geology. These are all different career pathways right in our backyard under one roof. So we hope that this talk today can inspire a few of you that are really science-oriented, that really love science, to know that there are opportunities that are endless out there that address the need to come up with more innovative solutions to our climate problems. So with that, with no further ado, I would like to introduce Vikrum Aiyer, who is the communications director for Heirloom, and his Heirloom team. Can we give them a really warm Tracy Unified School District welcome?
Hi everybody, my name's Christian. I'm here with my colleagues Freddie, Kirsten, and Vikram, and as Dottie mentioned, we're from Heirloom. It's a direct air capture company, as she mentioned, and we've just down the road from here in November opened a commercial direct air capture facility. It's the first of its kind in the United States. It's actively capturing CO2 from the atmosphere and keeping it out of the atmosphere so it can't continue to warm the planet. We're going to walk through today a bit about how that process works. More importantly, I wanted to start at the top about why we're in the business of removing CO2 from the atmosphere. Then I'll pass it on to Freddie, who's a research scientist at Heirloom, and Kristen, who leads our environmental health and safety program. So thanks again to Dottie as well for inviting us to be here. Really is a pleasure. So the why behind Heirloom starts about 200 years ago, when humans first started harnessing carbon or fossil fuels and burning it in order to build society. And in a lot of ways, that was a very good thing. It allowed us to travel, it allowed us to fly, it allowed us to grow food at a scale we'd never grown food before. It allowed us to mass manufacture a lot of the items that we all rely on every day. And throughout today, I want to kind of pose questions to you all. We've got some limestone cups and some heirloom merch that we're going to share with those of you who get the answers correct. But I wanted to just start by asking if anybody here can think of one way today that they've emitted carbon dioxide, one way that they've emitted carbon to the air. I saw that hand in the back first. If you just want to shout it out. Breathing, yes, correct. Correct. No, that was an easy one. We're gonna space it out. There'll be more questions, I promise you. Yeah, that was a good one. That's the lowest hanging fruit. If you drove here, you emitted CO2. That's another one. If you got dressed in the morning, it's likely that the clothing you produced had fossil fuels involved in the way that it got to you. It got to the grocery store, it got to the clothing store. In a lot of ways, we're very much wrapped up into this process of emitting CO2. Now, for 200 years, over this process of emitting, we've put out, humans, about 2 trillion tons of carbon dioxide into the atmosphere. And the problem with that is that once CO2 enters the atmosphere, it stays there. So even CO2 that was emitted 100 years ago, before any of us were born, will likely still be there 900 years from now. And it stays in the atmosphere, it traps heat, and I know a lot of you have a STEM background, so this might sound a bit obvious. I apologize if this is a little elementary for you, but that contributes to climate change. And here in California, you're seeing impacts of that, such as longer periods of drought. You're seeing stronger, longer-lasting wildfires around the world. You're seeing heat waves, stronger cyclones and hurricanes, and rising sea levels. I wanted to set that out at the beginning and then tell you a bit about myself personally. Right, it worked. How I personally got into this, and I think you'll hear the same from Freddie and Kirsten as well. I think if you're interested in getting involved in a STEM career, this sort of background information and how we got into this, I think, might matter to you. So I'm more STEM adjacent, so to speak. My background is in policy, but a lot of the industries that are going to be required to confront the climate crisis rely on policy. They rely on the political will of leaders who understand the kind of solutions and action that's needed in order to reduce the impact that humans are having on the planet. So my background, I was in public policy, and after my undergraduate degree, I majored in public policy. I moved to Fiji, which is a small island in the middle of the Pacific Ocean. A lot of low-lying Pacific Island nations face a very severe risk due to sea level rise. Some of these nations are only about 2 to 3 meters above sea level, and as the world warms and ice caps melt, that can push up sea levels and threaten their existence. So in 2015, it was Pacific Island leaders who came together around a goal to limit the rise in average global temperature, to get it back, or to manage it to a degree that was tolerable. So before we started emitting 2 trillion tons of CO2 in the air, we had an idea of what the average temperature was around the world. And since that time, it's risen by about 1.2 degrees Celsius. That's about 2.7 degrees Fahrenheit. Pacific Island leaders understood that if temperature rise were to go above 1.5 degrees Celsius, they'd face an existential risk. They'd risk losing their countries completely. So they came together in what's called the Suva Declaration in Suva, Fiji, to enshrine the 1.5 degrees Celsius aspiration. They took that to the United Nations, and they fought very hard with some other countries to ingrain the 1.5 degrees Celsius target into the Paris Agreement, which you may have heard of. Now, I have one fun bit of Fiji trivia for you, and we're going to put another, maybe an heirloom shirt in contention for this. Does anybody want to have a guess as to how many islands are in Fiji? Saw that hand first. 12, okay, we're going higher than 12, higher than 12. That was quick.
33.
33. You're off just by one digit, but it's a magnitude of order higher. Here.
43.
40. It's 3 digits. There's a hint. There's a hint. I'll go to this side. There. Right. Yep. You're looking around right there. That's close enough. Yes. It's 330 islands in Fiji. About 130 of them are populated. And well done. Well done. 33 was close. I was telling you. You were just sniffing it. But. I bring up the Fiji context because it really drives home the urgency of the sort of moment that we're living in, right? The 1.5 degrees Celsius threshold that Pacific leaders worked so hard to get into the Paris Agreement, we have a very short window left to limit temperature rise to that threshold. By 2050, we're going to need to achieve, what you've probably heard of, net zero emissions. That means we're not putting out any more CO2 into the atmosphere. Now, to get to net zero by 2050, this is a bit small, but I'll explain it to you all. To get to net zero by 2050, these are the pathways that are left available to us. In the business as usual scenario, so on the left column here, we have the annual amount of CO2 emissions we're putting out into the atmosphere. And over the x-axis here we have years. On the business as usual pathway, so if we don't change anything about how we're currently operating as societies around the world, we're going to fly past any chance of getting to net zero in time. If we only decarbonize, so if we only make decisions like choosing renewables, which we need to do, making homes and buildings more efficient, which we need to do, choosing more sustainable materials that go into our products, which we need to do. Even if we do all of those things, we're still not going to get to net zero in time to save the Pacific Islands and prevent a whole lot of other catastrophic climate impacts that are beyond 1.5 degrees Celsius. So as you can see here, it's a little dark, but our path to 1.5 degrees Celsius requires a degree of carbon removal, which is removing the CO2 that's already been put out into the atmosphere. That's those 2 trillion tons of CO2 emissions I mentioned earlier, our legacy emissions. It's also some extremely hard to eliminate emissions that are most likely still going to be around in 2050. These are very difficult sectors of the economy. Start talking about places, how we're growing food, how we're manufacturing certain materials. We're going to need to remove all emissions associated with those processes as well. And Heirloom was founded in response to that scientific mandate to remove that CO2 from the atmosphere. So there are a lot of different ways that you can remove CO2. Heirloom is one approach. As Dottie mentioned, we're a direct air capture company, so we're capturing CO2 directly from the atmosphere. That's pretty tough. CO2 is, you can't taste it, see it, feel it, but it's in the atmosphere in very dilute proportions, and we need to find a way to capture it and get it out. There are also suites of technologies that use the ocean to remove CO2 from the atmosphere. Other processes accelerate the natural ability of certain minerals to remove CO2. You can also, as Some of you probably know you can plant trees to remove CO2. The key is, though, that you want to be keeping that CO2 out of the atmosphere in a very durable way for essentially as long as it otherwise would be warming the planet. So that's centuries to 1,000 years. Heirloom combined two of these pathways in order to remove CO2. We combined direct air capture with carbon mineralization. And Freddie, who is on our research science team at Heirloom, is going to walk you through a bit about how we use a natural input of limestone to remove CO2 at the scale we need to. Freddie?
All right, hello. I'm Freddie. I'm a research scientist at Heirloom. And before I came to Heirloom, I was a student. I studied physics at the University of Pennsylvania. And towards the end of that, I actually did a research internship not too far away at Livermore National Lab. I don't know if anyone has heard of that place. And there I was doing geophysics research. Geophysics is the physics of the Earth. And then after I graduated around 2 years ago, I came to Heirloom and joined as a research scientist. So as a research scientist, I study the actual chemistry and physics behind all the processes that we do at Heirloom. And so my team works in the lab, we do a lot of different experiments, and through those experiments, we set the actual requirements for our system. What temperature does each step need to happen at? How much water do we need to add? How much airflow do we need? Things like that. And we take those requirements and we give them to the engineers, and the engineers use those requirements to build something that is actually going to work, like the plant that we just built here in Tracy. Also, anytime someone comes up with a new idea for how we might be able to improve our technology, the research science team is going to be the first one to actually come up with how we're going to test that out. But the original idea for Heirloom didn't actually come from us. We borrowed it from planet Earth. Yeah, I mean, as Christian talked about, humans have, for the last couple hundred years, been emitting a lot of carbon dioxide into the atmosphere by burning fossil fuels. And now humans like us are trying to build things that are going to take those fossil fuels out of the atmosphere. But for millions of years, before humans have been doing that, there are a bunch of natural carbon cycles that already exist in our planet. There are things that naturally emit carbon dioxide. There are things that naturally take in carbon dioxide in ways that for a very long time have balanced each other out. So I'm curious if anyone might have any ideas of what some of those natural things that take up CO2 in our Earth might be. Does anyone have an idea? Yeah. Plants, yeah. Plants, trees, everything like that, they all take in CO2. Anything else? Any other ideas beyond plants and trees? Yeah, what's up? The ocean, yeah. I'm surprised someone knew that. That's a really lesser known example. But the ocean is really, really important for taking up CO2. There's actually, right now, 38 trillion tons of carbon dioxide being held in our ocean. It's a very important part of our Earth for storing carbon dioxide. What's up? Limestone, yeah. Where'd you get that idea? Yeah, that's a great one. I wonder why we haven't thought of that. Limestone is super important. All kinds of minerals, not just limestone, but limestone is a really common example. There are a lot of different rocks in Earth's surface that soak up and store CO2. This one is a really common example. Calcium oxide, or lime, as you might have heard it called, naturally reacts with carbon dioxide, CO2, and it forms a chemical called calcium carbonate, or limestone. So who's heard of limestone before? Yeah, it's a pretty common one. It's actually one of the most abundant minerals on Earth, so it's really important for taking in CO2. The unfortunate thing about this, though, is that this process, when it happens naturally in our Earth, can take years, even hundreds or thousands of years. And that is not fast enough to prevent the climate trajectory that we're on right now. So it would be really great if we could extract some of this limestone, find a way to make this process happen in days instead of years, and do it over and over and over again, which is exactly what we are trying to do. So step one of our process is we take this limestone out of the ground and we crush it up into really small pieces. And then we take it and we put it into a electric powered kiln, which is basically a really, really hot oven. We heat it up to over 900 degrees Celsius. And the reason that we do that is because when you make it really hot, you actually take that limestone and you break it down into its original parts. It splits up into carbon dioxide, which is a gas, and that original calcium oxide, that lime, which is a solid. And so with the CO2 that comes off of it, we can capture it and we can store it permanently, and I'll talk later on about how we do that. And then the calcium oxide that's left, that lime, is the first step in that process I just showed you guys. So we could take some of that calcium oxide if we wanted to and spread it out here on the stage, and over many, many years, it would slowly react with the CO2 in the air and turn back into limestone. But like I said before, many, many years is really not fast enough. So we had to change something, and we realized that if you take that lime and you mix it with water, it makes a chemical called calcium hydroxide, or hydrated lime. And that hydrated lime can actually react with CO2 to make limestone in just a few days. So we take that crushed up hydrated lime and we spread it out in thin layers on a bunch of trays, like this one that's right up here. We spread it out onto these trays, we stack these trays on top of each other, we put them outside, and then as air from the atmosphere passes over these trays, the carbon dioxide in the air will actually react with that hydrated lime, get stuck to it. The hydrated lime will turn into limestone, and the CO2 will be stored in that limestone. So we take that limestone, we bring it back, we put it in that kiln again, heat it up, it splits up into carbon dioxide and lime. We capture the carbon dioxide, and then we start with the lime over again. We hydrate it, we put it outside, it soaks up CO2, we bring the limestone in, we heat it up, we capture the carbon dioxide, and we do that over and over and over again. And there's billions of tons of limestone in our earth, and so if we can harness just some of that and use it over and over and over again like this, we have the potential to remove billions of tons of carbon dioxide. And so if we go to the next slide, we can move from that little drawing to what you actually have here in your backyard in Tracy. If you look at those tall stacks on the right side of this left image that's labeled contactors, those are the big stacks of trays that I was talking about. That's where the hydrated lime is put into these really tall piles of trays. The air passes through that contactor, and the CO2 gets stuck to the limestone. And then when the limestone gets taken off of those trays, it goes, if you look at this image on the right, you see that thing that's labeled rotary kiln. It's that big box looking thing. That's where it gets taken to be heated up and split back into lime, and the CO2 captured off of it. And then the CO2 that is captured from it gets stored in those CO2 tanks over there. And eventually one of our partners will come, take those tanks, and permanently store the CO2 so that it can't go back into the atmosphere. But before I talk about how they permanently store that CO2, I want to point out that making something like this and operating it takes a ton of different kinds of people. It's a huge operation, and it takes a lot more than the four of us who are in front of you today. I'm wondering if people have any guesses, for example, of what kinds of different jobs it might take to build something like this and operate it. Yeah. Engineers, yeah, all kinds of engineers. We've got mechanical engineers who actually build the physical components. We've got electrical engineers who do all of the wiring. We've got controls engineers who actually control little robots that pull these trays around with the material on it and load it onto the contactors and bring it to the kiln. Any other ideas of some of the kinds of people that need to pull something like this off? Yeah. Welding? Yes, we need lots of welders. There's a ton of steel that this is built out of. We need welders to put it all together. All different kinds of trades, not just welders. We have welders who put the steel together. We also need construction workers to come lay the concrete and build the foundation. We need plumbers to set up all the water delivery. We need electricians to set up all of the wiring. This is a huge operation, and really all different kinds of skills, all kinds of people can be used to pull something like this off. I mentioned I was going to talk about how we permanently store the CO2, which is a really important piece because we're not just going to capture it and then let it go again. We need to actually make sure that it doesn't go back into the atmosphere so that it can't contribute to climate change. And there's a few ways to do it. Right now, the way that we're doing it is we're storing it in concrete, which is really interesting. We actually crossed paths with another company called Carbon Cure, and they invented a way to inject carbon dioxide into concrete while it's forming, so that it will be permanently stored in that concrete and even make the concrete stronger. And so that is actually the first and only way that CO2 has been sequestered in the United States so far, is with our partnership with Carbon Cure. Eventually we'll be removing billions of tons of CO2 from the atmosphere, and there won't be enough concrete to store all of that. So there are some other companies that we're working with who are working on taking that carbon dioxide and injecting it into the ground. You might be wondering where they inject it. Thousands of feet underground in a lot of different places, there are these huge pores in the Earth's surface. There are these wells that are empty. Some of them used to hold fossil fuels. Some of them are naturally occurring. And they can take that CO2 and inject it deep into those wells and then seal off the wells when they're full, and that CO2 will not be able to escape into the atmosphere again and contribute to climate change. But yeah, the sequestration of CO2 in concrete, like I said, was a world first. We did it with a much smaller version of what we have in Tracy. We built a pilot facility at our headquarters in Brisbane, which is where I work every day. And you see those stacks of trays, they're much smaller than the ones that are here in Tracy, but they soaked up enough CO2 for us to put it into that tank right there, and then Carbon Cure took it and injected it into concrete. And became a big headline. I mean, it was a pretty monumental day to have actually taken CO2 from the air that is contributing to climate change and actually permanently stored away into a material that we use to build with every single day. Then we decided to make history again by coming here to Tracy and building America's first commercial direct air capture facility. And I will pass it back to Christian, who will tell you what it means to be a commercial direct air capture facility.
Thank you, Freddie. So this is what's here in your neighborhood here in Tracy. It's a commercial direct air capture facility. And when we're removing CO2 from the atmosphere, the Heirloom business model, and we are in the business of stopping climate change, is to sell net tons of carbon dioxide removal to companies or countries that are using carbon removal to get to net zero, as I mentioned at the top today. So, back to this. So I just wanted to throw this list of companies up there because you may have heard of some of them, you may use some of their services every day. Microsoft, obviously if you're using word processing, you're using Microsoft's technology every day. They're one of our largest customers. So when we're removing CO2 from the atmosphere, we'll sell a credit that constitutes 1 net ton of carbon removed from the atmosphere. And when we say net ton, that means we're considering all of the CO2 that actually is involved in running the facility, capturing the CO2, ensuring that we're only delivering an additional ton of CO2 removed from the atmosphere. You'll also see Meta's up here. They're one of our buyers. They're obviously running Facebook and Instagram, which you may use. Probably not here, hopefully, but you probably do use in your lives. And some other major companies. These are all happening in the voluntary market. These are companies that understand the need for CDR as a part of their net zero strategies, and that's our customer base. I now want to introduce Kirsten, who's our lead on environmental health and safety, which is another critical part of how we run our facilities to make sure that they're done as safely as possible.
Good morning, everyone. I'm Kirsten. Raise of hands, who has no idea what they want to be when they grow up? Okay, you guys are much more confident than I was at your age. I went into college knowing that I loved math and I loved science, but I had no idea what I wanted to be when I grew up, or what major I even wanted to do. And I bounced around a lot and tried different majors, and nothing really stuck until one day my advisor sat me down junior year and was like, Kirsten, you have to pick a major or you're not going to graduate. I was like, okay, that's fair. And I really landed upon 2 majors. So I double majored in environmental health science and occupational health science. A lot of toxicology, biology, health and human science classes, industrial safety classes, environmental engineering classes. I knew I wanted to help people. I knew I wanted to help the planet. And again, I knew that I loved science and math. So my advisor told me to double major in these and then figure out what I wanted to do kind of after college. And with that, I also actually minored in dance, so highly recommend staying in the arts too and keeping yourself well-rounded. But yeah, I graduated from Purdue, still really had no idea what I wanted to do. I was even thinking about going in the Peace Corps, and ended up starting with Eaton in their leadership development program with environmental health and safety, which was an amazing experience. I got to travel all over and held a plethora of different roles, and within 3 short years, I was already managing teams of 10 people at the age of 24. And then after that, I moved out to California back in 2017 and started with Tesla, and you've probably heard about them. And started at their car division in automotive, went into solar, battery storage, as well as supercharging. And just over a year ago, I actually started with Heirloom, and it has been a really great experience. So throughout my whole journey, I have been in environmental health and safety. It's a great career. It's a great career if you love helping people. I come into work every single day with a new day, a new agenda. I never know, what the world's gonna throw at me, but I get to work with everybody in the organization, from technicians to our welders to assemblers, all the way up to, our CEO and leadership team, making sure we're making our goals and decisions with people in focus and in mind. So the major focus of my job is to ensure that we are abiding by OSHA and EPA regulations. But first and foremost, beyond that, it's protecting life. It's protecting our employees. It's protecting the communities that we work in, the environmental impact that we also have. And it's a really exciting career. I will say I had no idea what EH&S was, even back in college. All this to say, you guys all have the world at your feet right now. I'd say the biggest thing is, take those chances, put yourself out there. Taking a job for a year, even if it's not something you really know about or know that you want to do, maybe that job will help you figure out what that next job is and what you want to do next. Even when I was back in college, I spent a summer in Peru working in a hospital when I thought I wanted to be a doctor for a while, and decided I didn't want to be a doctor because of that experience. So highly, highly recommend just putting yourself out there when it comes to your career, and definitely looking into EHS. I get to work with all these great people, and my job is really, really exciting because of all of them. You want to go to the next slide? So these are some pictures of what I get to do every day, from dealing with major mobile equipment. Our kiln out there is about a 50,000 pound kiln that we have to get inside sometimes with a 24-inch radius. And to do that, we need specialized equipment, we need trainings, we need policies and procedures. I get to help create those and make sure our people are safe while we're entering this kiln that also gets up to 900 degrees. Respiratory training, I do a lot of training. This is our rigging and qualified signaler training. This was actually our lift of our kiln into place. A lot of safety components go into this, dealing with contractors and third parties. And I get to be a part of the team that makes the things that makes what we do. So yeah, I'm Kirsten. If you have any questions about EHS, I'll be after too. But thanks for having us.
Okay, I just want to say that was just truly outstanding. We got to hear about Heirloom. We got to hear about your professions. You guys are great speakers to our audience here. So we're going to do a little Q&A now and give you a chance to ask any questions that this might have, this talk might have caused you to start getting curious about some stuff. And we want to give you a chance to do that. So let's take some time. And I'm going to hand you all this mic, and I'm going to run another mic over, and we'll do some Q&A. Okay, if you have a, yeah, just, I'm gonna have you come on over here, we'll form a line, so come on down. Okay, great.
I was just.
Quiet down, everybody. We want to be able to hear all these questions.
Questions.
All right, go for it.
So I know some of you talked about this kind of briefly, but what made you want to get into this line of work?
So, could you just tell us your name as well?
Oh, yeah, sorry. My name's Brendan DeWitt. I'm a junior.
Very cool.
So I was just wondering, like, I know you touched on that a little, but like, what did you major in, and how did you get to doing this?
Okay. I think Freddie's probably the most pertinent background on the kind of direct line of undergrad to what he's doing now. So
Yeah. So I mean, I kind of was always interested in science and felt like that was my skill. So you know, I went into college and I picked science as a major. But you know, as I was going through college, I realized I didn't just want to do science. You know, I realized like when it came actually time to look for a job, like I wanted to actually do something that was going to make an impact. Make a difference, and you know, when you're in STEM, climate change is really one of those problems that you can work directly on and make a big change on. So yeah, I browsed this job board that was specifically for climate jobs. It's called Climate Base, and that's how I came across Heirloom. Yeah, sorry, did that answer your question?
Yes, thank you.
Awesome.
Hi, my name is Deer Patel. I was wondering how much CO2 is directly absorbed by like one tray of calcium oxide, and how long do you think it will take in order to put a serious dent in the high concentrations of carbon dioxide in the atmosphere?
Yeah, so each tray captures around 1 kilogram of carbon dioxide. Each stack of trays that you see here has hundreds of trays. And we've got how many towers of trays in the planet, Tracy? 36 towers of trays. 40 feet high, 36 towers of trays. And then we'll be building even bigger than the one in Tracy soon enough. We'll be going bigger and bigger and bigger, so that number will keep going up. To put a dent in climate change, our goal is to remove 1 billion tons of carbon dioxide by the year 2035. So that is 1 trillion trays, I think, of CO2, if I did that math correctly. 1 trillion trays, yeah. That's a lot.
Yeah, I think it's a great question, and we think about that question every day, basically. This first facility is just that. It's a first facility. It's got a nameplate capture capacity of 1,000 tons of CO2 per year. That graph I put up at the beginning, in order to kind of get below that line of net zero emissions, we're going to need to remove billions of tons of CO2 every year by 2050. And as Freddie mentioned, Heirloom's goal is 1 billion tons by 2035. It's a great question.
My name is Mo Shankar, and I was wondering, how would you measure like the amount of CO2 that the limestone absorbs? Like, how would you know if it's fully saturated with CO2 or not?
Sure. Yeah. So it's actually it's kind of simple. You won't believe it, but you know, as the material picks up carbon dioxide, it gets heavier. You can actually measure how much that mass is going to grow because we know exactly how heavy CO2 is. And so we weigh the tray periodically, and that's how we measure how much CO2 it's taken up. Yeah, and then you know, once we eventually do bring it inside and heat it up in the kiln and release that CO2, we can actually directly check that stream of gas that's coming out of the kiln and measure how much CO2 is coming off of it. But in real time, we use the weight of the tray. So yeah.
My name is Denny Midar. Thank you for your good presentation. My question is, what is your comment on global cooling as a result of dramatic carbon dioxide removal? As you mentioned how you're removing a lot of carbon, making net zero emissions. What's your comment on how it's going to affect our Earth?
It's a great question. So we know from the pre-industrial age, before humans started emitting CO2, we know the parts per million in the atmosphere of CO2 then, it was about 200 parts per million. Since then, in the 2 trillion tons of CO2 that have gone into the atmosphere since, we're at about 400 parts per million. So getting to net zero by 2050 is about stopping the rise in CO2 in the atmosphere, getting to that point. And then once we're at net zero, when we're accounting for all the CO2 we're putting out and removing that, then we can start talking about what are called negative emissions and taking on those legacy 2 trillion tons of CO2 in the atmosphere. You know, if we're going to be removing billions of tons of CO2 every year by 2050, it'll take us many, many, many decades to ever address the 2 trillion tons of excess additional CO2 that has gone out into the atmosphere since the industrial era. And we don't have the ambition or the ability to take it below what the concentrations that it was in the pre-industrial era, which is essentially what we view as like the carbon cycle, the correct carbon cycle, right? That's the 200 parts per million, but that's a very, very long way off. Right now, our focus is on stopping that concentration from getting too high and creating, you know, really catastrophic climate change.
I'm Suhan Narok, and as Danny said, thank you for coming today. Well, my question is, why did you guys choose Tracy as the location for your first factory?
Great question. I want to actually introduce Vikrum Aiyer, who is intimately involved with that decision. Vikram?
Tracy. First off, you guys have some of the best high schools, so we like that. Is that a controversial statement?
Yeah, a little bit more.
I think there's a couple of reasons why Tracy. First, you all know this better than I do, but Tracy has had a long history with really challenging air quality. And when we think about where we put these facilities, you know, you mentioned, you heard really big numbers from Christian a moment ago about what we need to do to get to the scale we need to manage this crisis. And so you need the Tracy facilities all over the world, right? And you need competitors of Heirloom to build them as well, right? This is not a competitive dynamic where we want to beat other corporations because we want to make money. This is just, we need an all of the above strategy where as many people are able to build these things. But when we think about the first, right? The first time that you're able to bring something like this online, we're a California company, so we wanted to make sure we did it in California. We know that Tracy has a challenge history with air quality, so we thought if you're going to be able to build these facilities that are basically rocks on trays and suck that CO2 out of the atmosphere, then to be able to scrub the air and kind of help clean the air, to do so at ground zero for challenged air quality, it was really meaningful for us. And we frankly found a lot of partnership and allyship in community here. And that's not a part that we talked about in the presentation, but I want to mention this because in the context of careers, my background, has anyone heard of Barack Obama? Yes, okay, sorry, that's an annoying question. Has anyone heard of the ACLU, the American Civil Liberties Union? Okay. Who said yeah on the ACLU? Or does that person who said yeah want to say what the ACLU does? No? Okay, all good. ACLU is a civil liberties group. And then who's heard of Uber? Folks have. Okay, so I've worked for all three of those organizations, including for President Obama. And so you don't normally assume that those three career opportunities, or working for a tech company like Uber or working in government, necessarily leads you to building a facility in Tracy, California. But when you work in those spaces, you realize that in order to build a facility like this, you need partnership with local governments, you need partnerships with local community groups, and you need partnerships with the neighborhoods and the residents themselves. And so that was my path to Heirloom, where I end up leading a lot of our community engagement and our community outreach for the company. And so when we met with groups like you heard from earlier from Dottie, the Tracy Earth Project, or we met with the mayor of Tracy, or we met with other members of the city government, we got a lot of support to be able to build this facility here. And so the fact that we could do this here in California, that we could do this here in Tracy, and we could do so with so much community support was really, really important to us. And I'll just end by saying, you're going to hear about more of these facilities in other parts of the world. And as each of these facilities come online, as Tracy residents yourself, it is all of our obligations to make sure that when these new technologies come to town, that we are asking, hey, I know you're another corporation showing up in our backyard, but what are you going to do for my city? What are you going to do for my community? I get that working on climate change is important, but what about jobs? What about internships? What about investments in after-school programs? I think all of that is going to be really important as we continue to build in Tracy, and we've seen a lot of partnership with local community organizations, and we just want to keep doing more of that. And so the fact that we are able to do it in Tracy makes us really excited, but we want to do that in other parts of the world as well.
Okay, we have 3 minutes. We're going to do this. I hate to do it because we do have to cut it off, but we're going to do 2 more questions. Okay, here we go.
My name is and I just want to ask, how has signing with Microsoft and these big business impacted your company as a whole?
It's a great question. So these agreements to purchase CO2 removal credits from a massive company like Microsoft allow us to basically build more of these facilities. So our latest deal with Microsoft is to remove about over 300,000 metric tons of carbon dioxide from the atmosphere. But the facilities that are going to deliver those credits haven't been built yet. Now, when we have an agreement with a Microsoft, we have specific prices and volumes for those credits over a 10+ year period. So when we want to go build that next facility, we can go to a bank or somebody who helps you raise the capital you need to build those facilities, and they'll essentially lend us the money at a lower rate because they know we have a product that has a guaranteed buyer. So for solar and wind energy, this kind of same model of long-term purchases is what really propelled the growth of renewable energy. Because they could go out and say, oh, we know somebody's going to buy our power, so we can build this facility. It's very low risk, and we know there's already a guaranteed buyer. It's the same thing for carbon removal. And so those deals are huge for us. They're hugely catalytic to let us build bigger facilities.
Thank you. Hi, my name is Iana Diaz, and I know you guys talked about how different roles go into Heirloom, and I was wondering what specific roles do biologists or people who specialize in biology have at Heirloom?
That is definitely a Freddie question, who is, I think, in the midst of candy distribution. Sorry, what was the question? The question is, what would a biology major, what sort of pathways for a biology major could lead to Heirloom? Yeah.
Okay. Let's see. So there's all different kinds of science that goes into our process right now, but I think the core of it is geochemistry, which is chemistry of minerals that naturally occur in our Earth. That being said, if geochemistry is something you were interested in studying, there is a ton of biology that goes into that because biology, like all kinds of living things, also, I don't know who I'm talking to, who asked that question. Oh, okay, sorry. I was like, okay. Anyways, there's a ton of living things that live in Earth's crust as well, and they really affect the chemistry of how those rocks form, including limestone. I think there's actually a specific field called biogeochemistry where you're studying how living things interact with minerals in the Earth. So I think that's probably like the most relevant way that someone who's interested in biology would be able to also do something that's relevant to the kind of stuff that Heirloom is doing. Yeah.
All right, everybody, we're going to have to end it there. Can we just give everybody that presented today a round of applause? They did an excellent job. And on your handout, I'll just remind you, on your handout, I'm going to turn this one off. Take this one. Thank you. All right, sorry about that. On your handout, there's some QR codes to learn more about Heirloom. There's also a nice plug for the Tracy Earth Project's Volunteer Youth Council. So please, if you're interested in getting involved, look into that. And I just want to say thanks for being a great audience today. I hope you learned something, and maybe we'll do some more of these. And Mr. Waggle.
Mr. Stein, you guys go ahead and exit first. Kimball, if you guys could wait for them to clear. Tracy, just wait. The bell will ring in a few minutes.
We're going to have Stein exit first, then Kimball, then Tracy. So thank you.